In this video, we're going to take a look at a second example where we find a hypothesis test or complete a hypothesis test dealing with the mean for a population. So here we have a sample of 19 green M&Ms, has a mean of 0.8635 and a standard deviation of 0.570 grams. We want to use a 0.05 significance level to test the claim. What is the claim? That the mean weight of all green M&Ms is equal to 0.8535. So here, when we identify this as a hypothesis test because it says test the claim. And what is the claim? It is a claim that the mean is equal to this value. So we identify the initial claim. Claim is and we write that symbolically. It's equal to 0.8535. We write the opposite of the claim. So what must be true if the claim is not true? So if it's not equal to 0.8535, it is not equal to 0.8535. So that's our counterclaim. From these two things, we should always be able to identify, should be able to come up with a null and alternative hypothesis. So the alternative hypothesis is always the one that does not allow the two sides to be equal. And so that's our alternative hypothesis here. It's coming from the counterclaim. The mean is not equal to 0.8535. And the null hypothesis, we just replace this sign here with an equal sign. It happens in this problem to come from the claim, but that is not always the case. So don't get in the habit of saying, it's whatever the claim is. That is not the case. It should always have just an equal sign here. So we've identified the null and alternative hypothesis. We have here 19, that value 19, that is our sample size, that is n. We have a mean here of 0.8635. That mean comes in this whole sentence that's dealing with the sample, right? So a sample of 19 has a mean of 0.8635. So that is a sample mean. So we use x bar for that notation, 0.8635. We also have in that sentence, so a sample of 19 green M&Ms has a mean of 0.8635 and a standard deviation of 0.570. So our standard deviation, S, 0.0570. That is a sample standard deviation because it's in this sentence dealing with the sample, and so all of that standard deviation is specifically tied to the sample. So that is not a population standard deviation, that is a sample standard deviation. And then we're also identify our significance level, that is alpha, is 0.05. So we're going to take this stuff and go to StatDisk with it. So over here in StatDisk, we are going to choose analysis. We are doing a hypothesis test. This hypothesis test deals with a mean and one sample. And so we choose that. The alternative hypothesis was that the mean was not equal to 0.8535. And so we choose population mean not equal to some claimed value. So that was already okay. Our significance level is 0.05, so that's okay. The claimed mean, this is the value that comes from the null hypothesis. So this is the hypothesis, the null hypothesis claim mean, and that is 0.8535. We input the population standard deviation. That was not known in this example. The sample size was 19. The sample mean was 0.8635. And the standard deviation that was associated with the sample is 0.0570. So those are all the values that we had identified earlier in part 1. And so now we can evaluate that. And so when we evaluate that, if we do the p-value method, we look down here and we see our p-value right there, 0.45 for, if I round to the fourth place, 0.4544. So that's our p-value. How do we make a conclusion based on p-value? We compare it to our significance level. So we observe that 0.4544 is greater than our significance level. So what happens when our p-value is higher than the significance level? If the p-value is high, the null will fly. So we fail to reject the null. So we fail to reject the null hypothesis since our p-value is high. So there is not sufficient evidence to say that the mean is not 0.8535. So there's not sufficient evidence of the alternative. It is reasonable to believe that it is reasonable to believe the null hypothesis, that the mean is actually 0.8535. Here, in terms of this t distribution, what we have here is a two-tailed test because we have a not equal to sign in our alternative hypothesis. And so with those two tails, we have two different regions of rejection. Between those two regions of rejection, there is a total area of 0.05. So between the two, we have 0.05. So there's like 0.025 would be the area here, and 0.025 is the area here. I got that just by dividing that 0.05 into 2. The p-value, what that means is there is some test statistic, and we find the area to the right of that test statistic, and we double it because we have a two-tailed test. The p-value is that doubled area there. So the p-value is that area because the area to the right of that test statistic doubled is more than the significance level. We reject the null. We are not in one of those two orange tails. We could also go through and use a critical value method. So that's our test statistic there. So our critical value method, going back to StatDisk, we have two critical t-values, plus and minus 2.101. And our test statistic, was right above that, was 0.765 if we rounded 3 places, 0.765. So since our test statistic does not exceed either of the critical values, so it's not Since our test statistic is between the two critical values, we again fail to reject the null. Beautiful. And finally, we could go through all of this again. We can think about a confidence interval method. So our confidence interval down here, they give us a 95% confidence interval. So 0.836 to 0.891. So that is the confidence interval that's associated with this. That confidence interval, we look to see, is the null hypothesis value, does that live in the confidence interval? Because that's a confidence interval that's built based on the particular sample that we have. Sorry, it's not based on the alternative, but it's based on our particular sample. 0.8535, that is in this confidence interval. So we do not have evidence of the alternative. It is reasonable to believe the null hypothesis. All right, next time we're going to take a look at what happens when we know the value of the population standard deviation.